Hello, welcome to Ed's Pinball Mayhem Workbench. Today I'm going to be showing you how to do some point-to-point wiring. Say hello in chat if you're out there, by the way. So this is a small, it's part of a game called Shoot the Bear. And in the bottom, you can see that it has a few capacitors. It actually has 5 capacitors in here. We got 2 in the can, and then we got 3 in the bottom. So this is a perfect example, a way to demonstrate how to replace capacitors in an amplifier, jukebox selection receiver, point-to-point wiring such as this. And what that refers to is, rather than being a circuit board where you're going to drop the components in, there's a nice little circle that says C15, it tells you plus and minus. It's point to point. So you got a capacitor that goes from here to here. Now the problem is it's not going to follow this. Well, it's going to follow the schematic, but it's going to be a little bit harder. Where it may say the resistor goes to ground, but you actually have to kind of go back and forth, find the grounds, and sometimes when you're dealing with audio, especially higher end, exactly where they ground it is important. So you got to try to tie it back to where it originally was. But this is actually just part of an arcade game from 1940 where it created a sound, kind of like a digital synthesizer almost, but using the tubes and a light bulb and some capacitors. It was pretty much just creating a growl sound for the bear to make when you shot it. That's essentially what this does. I wanted to show you how to replace it. Now, I've gotten some questions recently on some amplifier cap kits and stuff like that, saying, well, I need to replace the caps. I didn't think it was going to be this hard. Well, replacing capacitors in this isn't a entry level. It's not the first, I wouldn't start with replacing caps in a point-to-point in a jukebox amplifier or something like that, because it's not a entry-level soldering skill. It gets a little bit more difficult. And that's why I wanted to kind of show you guys some of the tricks or some of the tips to get you started on that. There's a couple challenges. Now, this one does not have a transformer on it because the transformer is actually in the chassis of the parts it plugs into. So if you're working on a rail-light game, gun game, or Seeburg of this era with this sort of sound maker, don't unplug and plug it in with the thing on, because you're dealing with 300-400 volts on these pins, and I don't know how that's going to affect the circuits if it's partially disconnected as you're plugging it in and out. I would just not. Another thing, I was watching a video of someone working on a tube amp recently. Before powering up any tube amp that hasn't been recapped in the last 25 years, there's a couple things you got to do. First, replace the capacitors. Visually check the resistors. Now these look all pretty clean. So if you look at them, the resistors are these brown carbon bands. They all look really clean. I would visually check them for burn marks, but another thing you can do is actually, if you want to go to the next level, do the best job possible, use a multimeter and test their values. And that's something that I'll show you a little bit as we're working. Now, they're all soldered together, so the best time to do that is when you're working on the recapping, because you're going to be pulling solder out anyways. So that's a good time to check your resistors. If you check all your resistors, you'll be able to know that that's good. So that's the first 2 things. So recap it, test the resistors, test your tubes. Now, everyone I see all the time, I just need all new tubes. All new tubes. That's why this sound lows. That's why this is. Tubes are not like light bulbs. They just don't burn out. They could be good. 80% is good on a tube tester. So if there's time today, I will take this 6v6, throw it on my tester on stream, and just show you how I would test it, just to verify basic it's good. Some tubes have 2 sections where it's not just one. Let's say transistor would replace it. It would be 2 transistors, or MOSFETs would replace it. So if I look at the schematic for this one looks like it only has 1 section. But the tube also has a plate load. It has a filament that heats up like a light bulb, and that heat allows the electrons to flow. So that needs to be lit in order for it to work. So that's all what we will test with this when we test this later. This also has a neon bulb. That's an NE-48, 105 to 125 volt little neon bulb. I believe that's used for the sound circuit. I'm going to put that off to the side right now. But we're going to focus on getting the cap done on this today. Now, unfortunately, I'm not going to be able to power it up because I don't have the rest of it done yet. Another thing I always start with is just give it a good clean. And I cleaned this yesterday. I just sprayed it down with some totally awesome, a little bit of a toothbrush. Got it looking pretty good. I protected the label. This was already partially ripped off before I started, so I just kind of put my, I made sure I didn't spray down or scrub into that area just to protect the writing on the label. You can see it says Growler assembly, and the first two digits of the serial number being 43, and it's by the J.P. Seeburg Corp. Chicago. So that's part of it. So that's where we start. So what do we need to get started besides your tools, soldering tools, assortment of wires, pliers, needle nose or tweezers, different pliers for working with the wires. I got a decent side cuts, and I got the capacitors here on the bench. So let's get started. I got my tools warmed up, I think. Let's check. Yeah, we're good. The desoldering iron always likes a little bit of time to warm up. So let's get started on the workbench. So I got my capacitors over here. I just got them laid out by value to make it easier for the stream. I don't have all the capacitors to do the selection receiver or the receiver, the amplifier as they call it, which actually is taking the signal from the vacuum tube photo receiver, amplifying it, and then counting up and then doing the actions. And so this is one of the actions, is the sound. So I got a schematic. This I think this came with my game. It's a pretty good quality print. I know Victory Glass also has Shoot the Bear manuals that come with the schematic in it. So I'm using this. I had a photocopy I found online. I wanted to kind of check some stuff out. The problem is this is extremely hard to read as compared to this copy or professional recopy that you get. So just be careful of downloading manuals online. It might be hard to read, and you may have to rely on some of the information in there. Another quick note I want to say is capacitor values have changed. So back when they were making these, they were doing 0.005 is one of the values. I don't have a 0.005. I may have ordered one. I ordered a bunch of caps yesterday, but then I realized I had enough to do this, and that's why I wanted to do this today. Happy New Year, Too Many Hobbies. Thanks for tuning in. So the equivalent of that today is going to be 0.0047. Capacitors, you can be within 20%. Electrolytic capacitors, you can actually be much higher. Voltage, you always want to be at the voltage that's rated or much higher. And there is a general rule of thumb. There is sometimes I've ran into where the value rated is not the value needed, and that was with some AMI selection receivers in circuits that use 50 to 100 volts, and they're using 600 volt capacitors. That's because they were also doing tube amps, and so this area they were using the same caps on the tube amps as they were for other areas where you don't need it that high. But that's just experience and looking at the circuit came into that. So generally speaking, especially if you're just getting started, always match the voltage or go higher. Capacitance, you can be within 20% and be safe, and electrolytics, you can actually be higher if you look at what they're doing. So these two electrolytics I can see are generally filters on the way in, so I'm not going to be concerned with going higher. This is supposed to be a 10 microfarad 350 volts and a 30 microfarad 350 volts. I have a 22 and a 47, and I got the right different values on order. If this doesn't work right, it sounds not right, I can swap it out later. Not too concerned with that. So having the schematic is valuable. Now this is the entire schematic of the whole game. So we have the gun base up here, we have the amplifier controller, AC1-L6, and then here is the different sections, like the wiring for the specific motor, the switches, everything is here, even the cabinet with the switch and the outlets, which is pretty cool. So I can verify every part is good. And this part right here, hard to see, is what I'm working on today. And that's why this schematic I found online is not very useful. It's just the AC1 amplifier. Put put that off to the side. I'm going to have this handy off to the side here, and let's get started. So there's 5 capacitors in this. 2 are this can. So this can will have 2 capacitors. These are electrolytic oil filled, and this can is rated for, it says, it should say right on the side, 30M 350 volt and 10M 350 volt. Now the 30M 350 volt has a little square after it. The 10M 350 volt has a little triangle. Now that is very, very important because there's 2 values in this cap. Sometimes the caps will be 22, 350 volt, or sometimes there are different voltage ratings in there. If they're the same value, it doesn't matter. But if we look at the bottom of that cap, we actually have 2 lugs and then the ground. So capacitors, 2 wires. And electrolytic capacitors are actually, it matters which way, they're polar. So the negative has to go to negative and the positive is the unmarked. On old electrolytic capacitors, the positive is marked and the negative is not, but you see this negative has that dash in the middle. Get it nice and close. You can see that. That means it's negative. If you have an older one, you'll see a black stripe with a plus in it for the positive side. So this is marked negative. Also length of the wires coming off of that. So you got 2 pins here. So you know, well, which one's the negative? Well, the negative is actually the case. You see the case is grounded back over here. The case is grounded, soldered in. On the top side, it's riveted. Sometimes if they don't want the ground of your cap to be the same as the chassis, you'll actually have the cap on a phenolic disc, and it will be separated, and you'll see how the wires soldered onto there. In this case, it's grounded. Now, it's going to be extremely hard to see, but on the back side of where this green wire comes in, I don't even know if I can get it on camera. Right there when I'm pointing, and right, you see here, right here, you can't see it at all. There's a slot where there isn't one. Here, there's a little cutout on the side. That cutout is a square. On this one, there's a little cutout on this red wire, red in resistors. That cutout is a triangle. So that's telling me right there what value. So the triangle is my 10 microfarad and my square is 30. So that tells me what value goes to which spot. And just so you know, with technology, this cap and one other cap is what's in here. So that's how, this is how much it has changed. That's why we don't need these big metal can oil-filled caps anymore, because I mean, this is more capacitance than both the capacitors inside here. And that's another reason why going a little bit bigger doesn't hurt, because I mean, at the time they went with what they had. So if we want a little bit more filtering and more better voltage coming in, DC voltage coming in, a bigger cap doesn't hurt. And that's this specific case. So what I'm going to do is I'm going to get started with replacing these 3 easy ones and work my way around. So I'm looking at this and I can see right here I got my 0.002 and that's my 0.25. And so the style of caps, these are a paper wax coated capacitor. It has the foil line, but that's not a positive line. That's just the side with the foil. These are wax-filled paper. This is plastic-coated paper capacitor. So I'm replacing that with a poly film. I like these yellow Illinois capacitor style polypropylene, I think, or whatever. They're a great replacement for these. And even if these look good and test good, replace them. Anything paper, of course, paper wax. These plastic, they're good, they're plastic, right? Well, they're actually, they can crack in the ends, moisture can get in there, you know. So I don't want to damage the transformer, because you can never get a new transformer. Or if you can, it's going to be expensive, it's going to be hard. I know the transformer has gone out in my game at least once, and I think there's a replacement. I hope it's all good. We hope, but so I'm going to start getting to work while I talk, but so this is my desoldering, and get my solder in here. So I'm going to start with I generally order my capacitors from. It depends on how particular the values are. If you're working on a like things like a selection receiver where it's not high end audio, something like that, where you just got to get close. I generally get my capacitors from Mauser. That's a good source. Sometimes with like a selection receiver, or whatever, a kit, I'll get the kits from like a supplier such as Victory Glass. There's Antique Electronic. I forget the website, but there's a website that has. They're known to have closer values. So if I really needed a .005 and I wanted to stick to them, they actually are known to have those. So what I did is I just kind of start with, I don't like to tie my capacitors onto other capacitors. Sometimes we do have to cut the leg off and hook it. I don't like to do that unless I absolutely have to, like the capacitor leads are short. And another thing is, when I get this out, these are what we call, let's see which one I'm working on right now. So these are what we call axial. So the wires go out the end, where this one here is radial, where wires come out one end rather than both ends. So axial capacitors are harder to find. They're more expensive. They're not in common use because circuit boards will always use the radial. What I did is I just kind of pulled the solder out of that joint, and now I identify which wire it is. And I just want to, I know I'm not going to reuse this, so I'm just going to pull it out. And what that's, we cut, make sure all the pieces come out. And it's good just to do one at a time or two at a time. I wish I had a stand to put this in. Yeah, the antique radio supply or something like that. They do specialize in them, and I know people said if you're doing a lot of it, it's a good idea to just get one of their kits of common values, and I could agree with that because high voltage axial caps are hard to come about. So the way I like to do this is I like to just kind of work a little solder in so you got some fresh elastic solder. By using this solder remover, I'm able to actually, look at that, just pull everything out of that area. And sometimes it sticks a little bit. You have to kind of pry it with tweezers or pliers to get it out. But there we go. We got .005 200. So that is actually this cap. So this is what I would call a axial. So the wires come out the ends. Good question. But because, put that out to the side, because this other capacitor here is actually soldered onto the same spot, I got to now remember that cap goes from here to here, and I'm going to replace this cap before I put that one back in. That would make more sense. So I'm going to try to remove this one. I personally like to pull them off the original locations as long as I don't damage them, and see how that's kind of sticking a little bit. But because I pulled the majority of the old solder off, I can actually just peel it off. There we go. If you're using, you can do this with wick, or you can heat it up. This is a tool I've had for years. After repair, I think it's for me a go-to tool. If you're doing repair or whatever, doing repair for someone else, I would say get solder removal. This is an old Heiko 470. They haven't made this for years. I'm just gonna. Once again, what I do is I'm putting a little bit of solder on the desoldering gun, and then I am heating up the whole area. And the trick with using these is keep holding the trigger and always go off. And I like to go vertical for a little bit to let go. Otherwise, you run a chance of getting it clogged up. A lot of people having issues with these tools or because they're just, a little bit of technique will go a long way. So that didn't do as great of a job as the other one. I was trying to move it while I was talking. But I am going to, oh, there we are. There we are. I don't want to cut the wrong one. Trying to move it while it cools will also help keep whatever one you're removing from sticking. See how it's kind of nice long nose, needle nose pliers. There we go. All right, so that's removed. Another one is out. That's 0.002. So I'm going to start by putting my 0.002 in. Now, it's very rare that the direction of these matter. They say the foil end or whatever, but for what we're doing today, it doesn't. But for future use, I like to make sure you can read these. Because this red one, when I went to go remove it, I couldn't read it because it was upside down. And sometimes it's used for, verifying the schematic is correct. Sometimes things change, or, when they're making them, like, well, schematic calls for this value, but we decided we needed to double it in order for things to work well because we're still in production. So if you look at this one right here, it's very readable. I don't know how close I can get. You can see the 0.25 MFD, 200 volt DC. It's really, really readable. So whenever putting in capacitors, I like to always take the time and be like, okay, well, I want to read it. I'm reading it this way I'm working. So I'm going to make sure that I put the label up facing me. And because these two are right next to each other, it's fine. I'm just going to feed that in there. This one has way too much wire, which is normally the exact opposite problem that you have when working on tube-based stuff. You don't have enough wire. Now it's winter. I kind of made myself a semi-New Year's resolution to get my games all working in my shop or in my arcade room, because I have a couple games that deserve to work, and Shoot the Bear is one of them. Okay, I'm trying to. So what I'm doing now is I am just getting this in and wrapping this wire around so I can physically hold it before I solder it. I always like to have a good physical connection before I solder it, because solder should just be the glue if you can. Sometimes you're at the mercy of some old electronics here. And the other thing I'm doing is I'm wrapping this wire underneath this resistor so that I have more room on the top for replacing the next one. I can even take this one and give it an extra quarter wrap. I'm going to cut it off here. Get a nice good wrap on it, but leave that hole open. And this wire here kind of slid off a little bit. Cut that wire just a little short. Now, one thing that really geeks people out is all the exposed wires here. Isn't that going to short together? I'm like, well, if you're worried about it, you can get insulators and you can put it in there. If you're not, generally speaking, you just watch where the wires go. And one other thing I'm going to point out is I'm putting in the 202, which is the 0.002, number 20. And let me check the schematic. Yeah, that's going to the ground bar, which is the chassis. So it's interesting to note that the center post in this bus bar is actually riveted to the chassis. So that is ground right there. That's why there's a lot of stuff that come to that specific one. So now, this one is replaced, but not soldered in. Do not make that mistake to forget to solder it in. Now, I could use my normal iron, but sometimes I just like to use my desoldering iron to solder these in because it's good and hot. Because I pulled all the solder out of every joint on that tab. So I need to resolder that. And hopefully you guys can see. I'm trying to get the job done, but I'm trying to also show you some stuff. So what I'm doing is when you're soldering in, you're not pushing the solder onto the iron, you're pushing it onto the tab. And I want a little bit more solder than that. Now, if that's too hot, if it's melting too much and it's flowing all the way down, that's where getting your normal iron out doesn't hurt. I'm just going to start by tinning it, hitting in the cleaner a few times. And let's give that. So I always put a little bit on the iron just to get it conducting. But then make sure your solder is melting onto the wires or the tab, because that's going to guarantee you're actually making good contact. The other thing is I always want to make sure I close the hole, because in the middle of this tab there's the hole that the wire goes through. I want to just close it up. Now that that's done, this capacitor ain't going anywhere. You can actually just make sure nothing's touching. Keep in mind that there is a board that this is mounted to. All right, so that's done. Next cap to go in would be that first one I removed, which is the 0.005. That's going to be the 472K, which is 0.0047. So I'm going to once again put that so I can read it vertically and just fish it through both points. Actually, let me quickly show just how to test these resistors in line. So when this one right here is going between those two screw points, I can actually check it via the schematic. That that should be R27. So I'm going to check what is R27. That should be a 470,000 ohm half watt resistor. Good schematics are always important. Now, something I ran into with a cap kit that someone was talking to me about lately was on the specific Rockola amp they were working on, they got a cap kit, but the values were not, the cap numbers were not listed. Well, because that amp didn't have cap numbers. It's all point to point, no cap numbers. That's even more difficult because you can't say it's R27 and check this. It just has, these are the values. And so the kit just had the values that you should be looking for on the schematic. But in order to find that, you have to actually say, well, it's going from this screw to that screw. Or it's going from ground to here, but where's this, these are tying to, because that's a floating point. That's where it gets complicated. That's where it gets harder to trace it, and it takes a little bit of work. So I'm just gonna 491, and I said 470, so that's within spec. So yeah, I could go, and sometimes you're not going to be able to read it without actually. There's another 492. It's the same spec. So now I know that this one here is the same resistor as that because of the color banding. This is a 4-band system, so I could go and check every one out. Sometimes you have to be careful if there's capacitors in there, if there's vacuum tubes, light bulbs, that can change the values. So that's where, when you're replacing the caps, is a great time to check all your resistors if you decide to do that. These are really clean. This is not known for heating up, but in an amplifier, especially AMIs, the plate load resistors almost always need to be replaced, especially an amplifier that's cooked all the time. This is only on when the game is being played and making noise, so it's not as important. All right, so back to putting this cap in. I am going to fish it through. Let's go back through that original spot up here. It doesn't hurt to give these components a little space, but they are going to run cooler than original. And I am going to wrap this around. So what I'm going to do, because I got a lot of joints here and I also want to push this wire back in, is I'm going to solder this side down here first. Therefore, nothing's going to be moving up on top when I'm soldering it in. So let me get that all, have that done. So once again, I'm putting a little solder on my iron just to make it conduct the heat to the joint. This is a big tab. I'm going to use the hotter iron. That's one thing I like about the having a desoldering iron around is it's hot. It's going to be quicker. You just have to make sure you don't cook things. See that solder just go right in. So yeah, notice I am not putting solder onto the iron because it's already conducting. That's good. The cap did twist a little bit. Now, before I solder that side back in, I just want to point out, if you look here, those leads are touching. Well, it doesn't really matter because they're going to the same post anyways. I can push this down, but they're going to the same post. So I'm going to now attempt to push this wire back on where it came from. I just grab that wire. Here you go. These are older electronics, so it is I'm using leaded solder. There's nothing you can do about that. Alright, it's a little bit more on. So I'm going to just melt. I'm using leaded solder because everything is already leaded. So you kind of, not a lead-free application. Okay, that's good. Alright, 2 down, 3 to go. This is, I'm using Kester. I use Kester rosin, what is it, 33%, 44? 60-40. 60-40 is what I use. This is smaller. Oh, where it says a size. There's this other stuff which is actually for point-to-point. This is 0.031. This is 0.040. So actually 0.040 is better. I like it better when I'm doing some point-to-point work because it you have to feed less solder through. But the 33 I like better when I'm doing board level, small ICs and stuff like that because it's a lot less. You're not dumping more solder in. You have a little bit more fine-tuned control. So now this one's going to be a little bit more difficult to get out. And there's a trick I can use to actually make it easier because it's junk anyways. I can actually get everything tangled up and cut one lead off. See if that did it. I'm trying to keep it moving while it's cooling because if things are moving when they're cooling, especially if you've done any soldering, you know that when you're moving stuff while cooling, not a good joint. It's going to pop off. Well, that's exactly what I want to do this time because I am trying to remove it without removing everything else. And luckily, I think in this case, the capacitors were the last thing added rather than the resistors. sometimes you can identify the wire and just cut it. And there we go. It's off. Once I get this out. There. All right, so one side's down. Now the other side goes right to the ground of the chassis, so that's going to be a right back here. So that's going to be a fun one. I know you guys can't see that. The reason why that's going to be more fun is because it's going directly to the chassis. It's kind of like a grounding bar on a circuit board. Because it says so much more metal, it's going to take a lot more heat to get this freed up. It's going to take a couple times to get it. So let's keep going. Now the good news is I got it mostly free. But I'm going to once again use the fact that I don't want to save this part as an advantage. And that's out. Okay. So now let's look at that closely. So this capacitor is significantly smaller than that one. See that? So I'm thinking about trying to tuck it in on the other side because I got these other two wires to deal with. So I need more room for these two. I'm going to try to tuck it in much smaller. Now both of those go back to here. And they go to wires. So that said, I want to make sure it's readable. See how much I gotta cut off. Yeah, there's a lot of excess wire on these, which is nice. Until you can cut off as much as you don't need when installing it. Just gonna angle. Okay, just trying. And this is where it can be quite difficult working on these, and that's why I've always tried. I never wanted to stream this, but there's more and more questions, and there's a lot. On top of that, there's a lot of opinions on how to do it right and wrong, and that's why I started off with this is the way I do it. Someone else is going to do it completely differently. And that's okay. That's fine. I mean, everybody has their way of doing things, and I'm not going to... I think it's valuable to show how I would do it. One thing to keep in mind, cutting all those pieces of wire out of the leads, you want to make sure that you're doing your best, that every piece falls out. You don't want it to be stuck on a component and causing a short. Another thing I'm doing with this is I'm pushing it away from this board. Give me a little space in case I have to use that tab here. I might have to use that. There. That's it. So that's a little bit more cozy. So now I'm going to solder this up. I'm actually just going to solder this side. There's a reason for that. I'm going to come back and I'll make sure everything is soldered later. Once again, I did rotate a little bit, but I can still read all these capacitor values. And I'm going to be using my desoldering iron to heat this up to solder in because it is a lug. I use this for lugs, but it's not. It is a big ground lug, and I want to make sure I get plenty of solder on there. And I have to make sure that when I'm touching the solder lug with this, not the iron. I'm not melting it on like dripping on a candle. I want to actually make sure that I get the lug hot enough to accept the solder properly, because that's a big mistake. And I'm making sure I get both sides of it, and also making sure I don't melt this wire. So there we go. I got the 3 film caps replaced. That's the easy one. Now, time to do the hard one. All right, so the hard one is, let's review for anyone that didn't see. This is an oil-filled capacitor. It has two values in it. They're electrolytics. The negative lug is the case, or the positive lug is these two tabs. On the side of the can, it says 30 microfarad or 30 M 350 volt in a square, 10 M 350 volt in a triangle. Looking at the back side of these phenolics cut in the bottom of there, I can actually see a square cut into there and a triangle. Sometimes it's stamped, sometimes it's printed. These are the best ones that's actually cut out in the phenolic, and the other one that's not marked, it would be the third one if there was a third value. There's nothing here, so that's what it is. So 30 meg is going to be my larger of the two. 350 volt is going to go to the square, and that is the green wire is going to get the 30 meg. Now the ground side, I'm going to have to use probably one of these holes on this capacitor. I already soldered that one in. I should probably not have. So I'm going to start by desoldering both of these, keeping these components separate with how they connect, and then I will fold down these legs and start putting in the other sides. So we'll see how this goes. Not really. This is the most difficult part to look good, to do cleanly. So this is where I'm going to just say this is the way I do it. Do your research and see if you can find the best way. And everybody is going to do this differently. So the red wire again is a triangle, and that is the 10. So the red goes to these two. I just got to get this out of the way first and try to sort it. Okay, see if that's enough to peel these wires back. I'm trying to preserve as much of the length of the wires as possible. That's good. That's on there really good. I have in the past, I have also ended up cutting the tabs off. There we go. There's one. Ooh, that's this one. All right. Okay, that one. One down. Two to go. Two down. The last one is this little red wire, and this is my 10 meg ohm. Alright. Okay, all three of these here go for that one. What I'm going to do is I'm going to fold this down. You can cut them off sometimes. You can fold them down. I like to leave the aluminum cans on top. There's a few other, like, there. I like to fold it down and just jam it down in there. I'm not going to use that anymore. Okay, so those three go together. Now I'm going to take these two resistors with the orange on them. That's going to be my mental, and the green. That's the, I'm going to take those two and I'll pull those off next. So the resistors with orange goes to the green wire, which goes to the big cap. Alright, so here we go. Oh, you can smell that old solder. I can just get something broken loose here, I'm sure I can get the rest of it out. I need to pull more solder out. Now, it doesn't hurt if you need to pull more solder out to put more solder in. I know it kind of sounds wrong, but it helps it conduct, helps it kind of pull better, helps it makes it more flexible. I got to get down at the bottom of this, so okay, let's see, did that do what I needed it to do? Yes. Okay, I think. Let's see. There we go. Another thing I didn't mention, but I just want to point out now, is when, after doing all this work, when you're bringing up a old amp, you always want to bring it up slowly. And what that means is with a variac or something like that, where you can, don't just give it the full line voltage, full 110 right away, because that's going to be where problems happen. That's where people accidentally melt. It's more bending than I wanted to do. I don't know if I have replacement resistors for these. Okay, one down. So what you do is you hook it up to a variac, and that is something that allows you to change the AC voltage for the line coming in. And so you start at like 10 volts and you slowly bring it up, checking for something smelling or possibly things damage. It helps brings the capacitor values up. It's generally it's a way you're going to protect your transformers. This is the part I dislike the most about doing this, is because you got a situation where it's in the most pieces, you got the most damage done to it. There, 2 down, 1 more wire, and then you have to put it back together, and it's never going to look as clean as original. Sorry guys, beat me up in the comments. There, okay, it's done. So what I'm going to do is I'm going to route that other wires out of the way. I'm going to take that and push that all the way down as well. A little bit of solder on the back. I'm just going to clean that up. All right, so now I got to put the last 2 caps in. Fun. And this is where I'm just looking at these 2 oranges and the black wire go together to the cap, and then these come together and they all have to go to a ground. So there's 2 ways I could do this. I could use this unused lug. I don't want to use this ground lug. That's going to be way too much. And I just want to let you know, I did not plan this out ahead of time. I wanted to go through the pain together, guys. If I put this cap here, you can always use like an existing lug like this. You can use I got another one, like these bus bars, to try to tie them together. So this is challenge here. So what's going to be the cleanest way to do this? These 3 orange wires and the 30. There's this big boy, or these small ones with this small, sorry, these go, this one will go to those 2. So I am thinking. those three, how long is that wire? Huh. I bet I could put this guy right here. And tie everything to this pin right there. Okay, I'm going to do that. Going to be my 10. Use this unused bus bar location. Nice clean connection there. Not long enough. Okay, what about this? Is this long enough? Yes, that's long enough. Okay, so I'm going to have to lengthen that wire. There's a trick for that I'll show you. Actually, this wire, feed around the back side here. Okay, I know the center pin is ground. Let me just check. Everything goes to the same spot, so it doesn't matter where. So I'm going to actually pull the solder off of the center pin that I already put back on, because I want to hook up another wire there. I didn't wait long enough. Uh-oh. Uh-oh. Looks like failed my desoldering. Ooh, yeah, she's bad. Clean the rest of this out better later. I'm not on stream. Yeah, all right. Back to business. All right. That's why I didn't clean it out as good. Once again, I'm putting in she's getting a little plugged up. A lot of times when you're using desoldering tools with electronics such as older stuff, that resin and the junk you pull off, the dust on the wires will plug up your desoldering tools quicker. Okay, so back to where I was. I got that wire run. These oranges and these greens go to the 30, so I got my smaller capacitance one. And this has got to cross over dangerously close to this. So that is where this little material comes in, this little fiberglass tubing. Put a piece on the negative lead. And then I can just feed that through. Now, in a pinch, if you don't have that, a lot of times on old point-to-point tube stuff, you'll be pulling it out and not using everything you put back in. You'll have some black stuff like that. And in a real pinch, you can strip a wire. just take a piece of solid core wire or insulation and just strip a little insulation off and use that. I'm trying to do this kind of nice and clean, and so nothing's going to short in the future. There we go. Okay, I got it through there. We really don't want to short anything. All right, I'm going to leave that unsoldered. Now this is a little bit of a hack I have to do. Not preferred to do this, but once you see the other way of doing it, which would be okay. So we're going to get a good mechanical connection. And solder. Okay. As I said, not the finest way of doing it, but you know what? It works. I'm doing this for myself. I don't do this kind of work for other people because I know if I'm taking a risk doing something a little bit different, it's on me. Alright, so now I'm going to solder in that left side real good. Make sure I fill it with solder. I want everything to have a good solid connection. New solder is always a good thing, nice elastic. Old solder can get brittle. Okay. That's one down. I still got to solder up this point and this point because I pulled the solder out. And I'm going to put some tape on this just in case. It shouldn't get pushed down, but it's a hack I got to do. So now this side, this is going to get interesting as well. I have to solder this in. And one reason why I purposely removed this wire to the other side is I need a little bit more room here for this capacitor. So I'm going to do is I'm going to fish this ground through that hole in the original can. Knowing that that can is soldered real good on the other side. Give it a good wrap. And I'm positioning this other wire straight up. I know it's not preferred, so you can't read the value. But here I'm mostly concerned about wire position. Alright, I'm going to solder that down. I'm going to solder this other down. I'm going to solder everything except for those last wires. Those are going to be again, I'm using a hotter iron because that's a big lug to solder to. solder this here. Get this here. The reason I'm switching from the hot iron to slightly cooler now that everything's warmed up, I just don't like to flow everything. If it's too hot and you keep using the hot iron, you can flow things out. You don't want to do that. All right. So I have this one sketchy solder joint here, and the rest of this is looking all right. Now you can use zip ties or tie downs or even glue if you have to keep things from moving if you're concerned. I'm not concerned about this. This wire actually should be pretty good as long as no one bangs into it. And when this is sitting bolted on the cabinet, even though that's way out there, that is not going to be a problem. Look at all these wires and connectors just hanging all out there. So next is this last connection, which is the 2 wires with orange on it, 2 resistors, that capacitor. This is where it's best if you can attach, if you have room to attach like a binding post where you're not attaching to the ground, to the chassis or something like that. But I don't have much options here, so I'm just gonna have to combine these together up in the air, unfortunately. That's why I made sure that the capacitor was good and anchored on the bottom, and that's why I might come back and just put a little glue of some sort on the capacitor to keep it from shaking around. But truthfully, as long as these wires are not in any way that they could be shaken and pushed into the another wire or the case, we should be good. I'm purposely pointing it towards the edge here, because I want to get this green wire on. In a way I could wrap it the same way around. There are people that are 3D printing some wire holders, which are something that if you have room in the chassis, you can drill a hole, screw them to the side, or sorry, capacitor holders that actually hold them in place. You will find yourself still needing to lengthen some wires or some leads. I know those are popular for like some of the Seeburg SHP amps. People make them. What I'm going to do, I'm going to point this down and away. And I'm going to solder that up. Yeah, I'll use this one. A little bit of cleaning up here. Now, if you say, hey, you could touch that when you're messing around with the chassis or moving it. The other side of this is the wood cabinet, and there you would not have this energized at all and have this up here to mess with it. Okay. So what I'm going to do a visual check to make sure that that wire can't touch there. This is separated here. I personally believe it'd be very difficult for this wire, this to touch anything. This here, if I want to, I can do. I can throw a little bit of solder on right there. that did is now this is even more stable. This could be smashed down into that resistor. That's probably the only concern I have with doing it this way. Everything's nice and tight. I don't know if you notice, I did accidentally solder this capacitor tab to the ground here. That's okay. These should be grounded. Them touching or soldered to the ground is not a problem because that capacitor, these values are now dead. So we don't want them to exist, but we don't want to have a big hole. Another way to do this would be to drill this out, remove the can. People have re-stuffed cans. You could have the two capacitors sticking up and cut a piece of this and glue it on top through the phenolic. I've seen a few different things that people have done, but this is one way of doing it for me. Now let's just check this. I'm not touching any leads. So as far as that is good for me. Put that in there. All right, well, cool. So that is recapped. As you see, that was just 5 caps. It takes time to do it right. It takes time to do it in a way that you're happy with. Last thing I got to do before I say this unit is good for install, just put some stuff away here, is test this tube. I'll clean up my bench post-stream. I don't even know if the tube tester will fit on the stream. Let's see. Oh, there we go. All right, so I got to test this tube. This is a Jacobs 648 tester, or Jackson 648-1. This tube would go into that spot. I'm not going to plug it in yet, and I'm going to plug the power cord in. All right, so I'm plugged in, live power. I'm going to show you how I'm going to test this tube. I am going to, when you clean these tubes, try not to clean the label off. This is a 6V6. 6 refers to the filament voltage, so I can tell you it's going to be 6.3 right now. 6V6, I did not plan that, it's right there. All right, so let me stand up. All right, so 6.3, 6V6, 6.3, D, 1, 2, 3, E, 4, 5, 6. Plate test is here, 35. I'm going to plug my tube in. Now, first thing I'm going to do is I'm going to turn it on. And I am going to let it warm up. Don't know if you can see, but this is warming up the heater. So if I test the W test now, it's going to be bad because it's still not warmed up. So you can see the long, if I hold it, it's going up. It's because it is still heating up. So you gotta give it a little bit of time. That's why I always throw the plate test down to 0 between testing. That way I can actually set the filament voltage, turn it on. These tests down here aren't used until you press the W to test how it tests the circuits. So I could have been heating this up a little bit sooner. So what I'm going to do is test the W. This is in fact a bad tube. So generally it's a 70% is good. I like to go 80% or higher. If you get above 130, it's also bad. So I can turn this off. I can just make sure I got good connection here. Tapping it, you can check the shorts, leaks. But yeah, that's a bad tube. So I'm not going to put this tube back in there. I'm going to find another tube and test again. So used tubes aren't always bad, but they're always worth testing. Now, if you have something that, like a 12AX7 that has 2 circuits in it, you want them both to test about the same percentage good. So if I have a 12AX7 and one side tests 80% and the other side tests 120, I gotta look at the circuit. If both halves are being used, I want it to be good, especially because 12AX7s are used for preamplifiers with audio all the time, just like 12AU7s. Rectifier tubes are always worth testing. Those are important. If you have paired tubes like two 6L6s, which are in audio, your amplifier tubes or EL84s, no, that's wrong. Anyways, you want to just have those as well be about the same percentage. That's not matching it, but that is one way of testing. So, in short, we got a bad tube, so that is worth testing. Turn that off, pull that out, and that is that. So, thank you guys for tuning in, for watching me replace the caps on the Growler. It took a little longer because I'm trying to describe what I was doing, and you can see I just wanted to show you the tricks, the challenges you run into with those electrolytic caps and the values. Hopefully this is a foothold, a step towards being able to do it yourself. And the biggest thing is doing it. You got to take some liberties with those oil-filled caps. Do some research. There's a lot of people that do it, and a lot of people will do it wrong. A lot of people do it right. There's a lot of opinions on how to replace those caps, and that's where you got to form your own opinion, but also just think what's the safest for me, what am I comfortable with too. So please don't beat me up too much in the comments, because that's how I did it, tying those two together. But this is educational. So thank you very much, guys, for watching. Look forward to more videos working on the Shoot the Bear, or when I start putting it back together. So thank you very much. Make sure to subscribe. Make sure to like. We're going to be doing some more streams this winter on just general repair on the bench. So until then, have a good one.